Assalamualaikum warahmatullahi wabarakatuh, and good morning, ladies and gentlemen. First of all, we give thanks to God, Allah Subhanahu wa Ta'ala, who has given guidance, mercy, health, and happiness for us to join this event together. We are delighted to welcome you all on this beautiful Wednesday morning, September 8, 2021, as we commence our event, the third International Seminar on Science and Technology, or ISST 2021, the path of sustainable development for a better life. Furthermore, we would like to express our gratitude to the Rector of Tadulako University, Professor Dr. Insinyur Mahfuz MP, who is represented today by Vice Rector for Development and Cooperation Affairs, Professor Dr. Insinyur Amar SCMT. Mathematics and Natural Sciences, Tadulako University, Ibu Darmawati Darwis, PhD. Additionally, we would like to give a special welcome to the honorable keynote speakers today, Professor Tatsuya Oshima from University of Miyazaki, Japan, Professor Dr. Kuatriana MSE from Gajah Mada University, Indonesia, Dr. Xiao Ching Cho from University of Newcastle, Australia, Dr. Muhammad Rafi MSc from IPB University, Indonesia, Professor Chong Woong Kim from Gwangju Institute of Science and Technology, South Korea, and Professor Dr. Andri Dianugraha from Bandung Institute of Technology, Indonesia. Lastly, a warm welcome to all distinguished guests of this seminar. We are honored by your presence this morning. Without further ado, let us begin with the first item on today's agenda, which is the Indonesian National Anthem, Indonesia Raya.
We cannot hear.
Pak Elisa?
We cannot hear. Okay, now we can hear.
Thank you very much. Ladies and gentlemen, next, let's watch together the profile of Tadulak University.
Universitas Tadulako has become an independent national state university since 1981, after previously established only as a branch of University of Hasanuddin in the period of 1966 to 1981. Universitas Tadulako is one of the fastest growing universities in eastern part of Indonesia. Located in Palu, a vibrant capital city of Central Sulawesi province.
We are really pleased to welcome you in our lovely university. Tadulako University is a gate of inspiration, desires, and excellent community services through education and research. Our university organizes a modern, innovative, and relevant education, conduct high-quality research and community services, and also establishes a good cooperation with its stakeholders. We are very proud to be with you. Together we can make it.
As the biggest and the fastest growing institution in the province, Universitas Tadulako has an enormous opportunity to contribute to the quality, aspiration, and success of the next generation. Universitas Tadulako has become the center of science, culture, and art with a significant aim to unify people from various backgrounds. Located about 15 kilometers downtown, surrounded by abundant green areas, Universitas Tadulako is able to provide comfortable learning, teaching, and research activity environment. In Universitas Tadulako, we have various choices of study to offer, both for undergraduates and postgraduates, in order to cater different individual interests, encountering the dynamics of our fast-changing world. More than 40,000 college students applied. Over 30 of them are international students from several foreign countries. International students can be assured that they will receive all supports that they need while completing studies in Universitas Tadulako. Studying in Universitas Tadulako means that students will experience challenges, inspiration, and support, of relevant learning opportunities, and be equipped with outstanding skills and knowledge. Today, Universitas Tadulako has 11 faculties, over from undergraduates and postgraduates program. Faculty of Teacher Training and Education, Faculty of Social and Political Studies, Faculty of Economics, Faculty of Law, Faculty of Agricultural Sciences, Faculty of Engineering, Faculty of Mathematics and Natural Science, Faculty of Forestry, Faculty of Medical and Health Sciences, Faculty of Animal Sciences and Fishery, Faculty of Public Health, and Postgraduate. In supporting the core aim of Universitas Tadulako to be the center of knowledge, technology, culture, and art in Central Sulawesi, Universitas Tadulako is equipped with main library linked to 11 faculty libraries, an international affairs office, a language center, a herbarium, an information and technology center, and a research center. In addition to that, Universitas Tadulako is also opted by growing numbers of international students coming from Papua New Guinea. Timor-Leste, Thailand, Vietnam, and Egypt. In the effort of strengthening academic quality to meet Universitas Tadulako has established mutual collaboration with a number of higher education institutions in Indonesia and overseas, such as Thailand, Australia, Taiwan, Japan, Vietnam, and the People's Republic of China.
Well, ladies and gentlemen, the next item on the agenda is recitation of prayers. We welcome Mr. Syafruddin Penda to lead the recitation of prayers.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, today I will recite a prayer in Islam. For the rest, please conform with your faith. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Ar-Rahmanirrahim. Malik yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. In the name of Allah, the Beneficent, the Merciful, praise be to Allah, Lord of the worlds. Let your blessing and your peace be on your servant and your messenger Muhammad and on his family and his companions. Allahumma ya Allah, on this glorious day, in conjunction with the opening ceremony of International Seminar on Science and Technology, we uphold our hands to pray gratefully, to thank on your infinite favor to us, till we can live in peace and harmony, to perform our tasks as your servants. Ya Allah, we ask your blessing to make this occasion a success. Allahumma ya Hayyu ya Qayyum ya Zal Jalali wal Ikram. You are the mercy of the mercies, and you are the Lord of the universe. Give us mercy from your presence, and save for us right conduct in our flight. We ask for your knowledge which is beneficial and sustenance, which is good, and deeds which are acceptable. Ya Allah, help us to remember you, to thank you, and to worship you in the best of manners. Forgive us, have mercy.
Sarkiani.
Okay, we apologize. Sometimes we get a problem with the connection. Thank you very much, Mr. Syafruddin Penda, for leading the recitation of prayer. Ladies and gentlemen, the next item on the agenda is the welcoming speeches. The first will be delivered by the chairman of the third ISSC committee. Please welcome Bapak Elisa Sesa, PhD.
Thank you very much, Mrs. Sarkiani. Good morning, everyone. Honorable, all the Vice Rector, Dean, Vice Dean within the Tadulako University, especially for the Dean of Faculty of Mathematics and Natural Science, Mrs. Darmawati Darwis, PhD. Your Excellency, to the keynote speaker of the third International Seminar on Science and Technology, Professor Tatsuya Oshima from University of Miyazaki, Japan. Professor Kim Jong-woong, Gwangju Institute of Science and Technology, Korea. Dr. Sejong Su, from the Center for Organic Electronics, University of Newcastle, Australia. Professor Dr. Engineering Kuat Triana, MSc, from Gadjah Mada University, Indonesia. Professor Dr. Andri Dian Nugraha, MSc, from Bandung Institute of Technology, Indonesia. And the last, Dr. Muhammad Rafi, from IPB University, Indonesia. The honorable distinguished guests, all participants in this seminar. First of all, thanks to God for the good day today, where we are given opportunity to join this international seminar in a good condition. And yes, that's very something like not really happy because we have a connection is very good, not good, but yeah, that's happened sometimes. Yeah, not the same all the time. The same. We don't. Sometimes we don't expect it. So this seminar is a series and an annually activity to the faculty, and we did the seminar also is to commemorate the 40th anniversary of Tadulako University. So we are already 40 years now for our university, and then the 14th anniversary of the Faculty of Mathematics and Natural Science. So something like still young, yeah, at the moment. Then this international seminar is attended by lecturers, researchers in wide related fields of science and technology. The participants come from Paris University, research institutes from 7 different countries, from namely Australia, India, Japan, Korea. We have from Mongolia, Malaysia, and of course, Indonesia as a host. There are 108 papers, yeah, abstract already accepted to be presented, will be presented virtually through parallel session later. Through this opportunity, on behalf of the ISST committee, I would like to thank the Rector of University Tadulako and the Dean of the Faculty of Mathematics and Natural Sciences, University Tadulako, for all the given support for the implementation of this seminar. So we also hope that after the seminar, we really have something like more future what so we're thinking as wide collaboration, international collaboration, or national collaboration with other university with the field we have. Ladies and gentlemen, our highest gratitude goes to keynote speaker, already mentioned before, Professor Tatsuya Oshima, Professor Kim Chong-Woong, Dr. Xiaojing Shou, Professor Dr. Engineering Kuat Triana, Professor Dr. Andri Dian Nugraha, and Dr. Muhammad Rafi. We also extend our great appreciation to the participants who came from various public university, as well as department or non-department institution from the countries we say before. And the presence you in the seminar contributes to the advance of science and technology. Our deep apology, yes, what's happened if during this activity there are things not pleasing to our noble speakers, presenters, or all attendees, guests that come to this opening session. We again our apology. We congratulate you on participating in this seminar and wish you all the best. Thank you very much, Mrs. Sarkiani. Back to you.
Thank you very much, Failisa, PhD, for your speech. Well, ladies and gentlemen, the second welcoming speech will be delivered by Rector of Tadulako University that will be represented by Vice Rector for Development and Cooperation Affairs, Professor Dr. Insinyur Amar STMT, as well as officially open our event, the third International Seminar on Science and Technology 2021. Time is yours. Prof. Amar.
Okay. Thank you very much for moderator Zarkian Hasim. Before I begin the speech, I would like to convey the best regard from the Chancellor of Tadulako University and apology from him from not being to attend this moment because there is another agenda and he represents me. Assalamualaikum warahmatullahi wabarakatuh. Good morning, all the greeting kindness to all of us. Honorable all Vice Rector and all Dean, especially Dean of Faculty of Mathematics and Natural Sciences, Tadulako University, Darmawati Darwis, PhD, all Vice Dean, Conference Chairman, Elisa Sesa, PhD, all Study Program Coordinator, all lecturer and Civitas Academic and Mathematics and Natural Sciences Faculty, Tadulako University. Excellency, the keynote speaker on the online third international seminar on science and technology 2001 today, Professor Tatsuya Oshima from University of Miyazaki, Japan, Professor Chong Won Kim from Guangzhou Institute of Science and Technology, Korea, Dr. Xiongzi Cho from Center for Organic Electronics, University of Newcastle, Australia, Professor Dr. Engineering Kuat Triana, MSc from Gadjah Mada University, Indonesia, Professor Dr. Andri Dianugraha, MSc from Bandung Institute of Technology, Indonesia, and Dr. Muhammad Rafi from IPB University, Indonesia. Distinguished guests, all the organizing committee, and all participants in this online third international seminar from Japan, Australia, India, Malaysia, Korea, Mongolia, and Indonesia as the host, that I'd highly appreciate. Ladies and gentlemen, first of all, let's pray and thanks to Allah Subhanahu wa Ta'ala, who has been giving us some mercies and blessing so we can attend and gather this online seminar in good condition and happy situation. My salawat and salam are always given on our Prophet Muhammad sallallahu alaihi wasallam, who has taught their people respectfully in order to attain a happy and prosperous life in this world and hereafter. It is my pleasure to welcome the keynotes and invite speaker to deliver knowledge and share their experience in the topic of the path of the sustainable development for a better life. This seminar is proudly organized by Faculty of Mathematics and Natural Science, Tadulako University. I appreciate the effort conducted by Faculty of Mathematics and Natural Sciences. Ladies and gentlemen, at the moment, I wish a happy 40th University of Tadulako University, which coincide with the 14th of August last month. Currently, Tadulako University is the atmosphere of the different educational climate than its previous year. This difference is very noticeable in the learning process or teaching and the learning activity that require us to use an online system. Even so, academic condition must be continue to be created both by teacher and by learners. In this case, our student that we love. All university throughout the world are not expecting Indonesia is feeling the effect of the coronavirus disease, COVID-19 pandemic, but it doesn't preclude any activity that have been professionally planned. One of which is the online third international seminar that is taking place here today. Ladies and gentlemen, as far as I know, both science, and technology can be integrated comprehensively to both the development achievement. However, we need development that improve the quality of life for human being. Generally speaking, the scientist has already made a significant contribution to the development, but the understanding of the sustainability of the development needs to address, especially during the seminar. I do believe that during the 2 days of the seminar, it is impossible to cover all of these important issues. But from this forum, I wish you and all can identify the main problem that we would like to be addressed. We can share and learn each of the other in this forum. We hope we can engage more collaboration within the near future in the area of science and technology with the speakers today. Therefore, this phenomenon becomes a very important basis that underlines to the themes of the online Third International Seminar this time, with the topic at the path of sustainable development for a better life. I hope with the presence of the reliable presenters in their respective file can broaden our insight, how to improve and enriching science and technology in the digital area 4.0, especially in the era of the COVID pandemic. Ladies and gentlemen, I will appreciate to all staff and committee of the Mathematics and Natural Sciences and International Office for the initiative and intensive effort to run the seminar at Tadulako University as part of the effort to strengthen our collaboration with the other institutions around the world. On behalf of Third International Seminar on Science and Technology Committee, all associates, we wish all the participants have great achievement of success and to fulfill the expectation as well as enjoying in the interaction with our speaker and participant. Ladies and gentlemen, finally, and on behalf of Rector of Tadulako University, and the name of Allah subhanahu wa ta'ala, by saying Bismillahirrahmanirrahim, I open officially this online Third International Seminar on Science and Technology 2021, and congratulations to you all to gain as much knowledge as you can at today's. We are looking forward to meeting you all in the future seminar continue. Thank you very much for your attention. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you very much, Bapak Profesor Dr. Insinyur Amar SCMT, for your speech and opening this event officially. Well, ladies and gentlemen, at this time, we will have for the session that will be taken by Ibu Igna Aquila Kalista. Ibu Igna.
Thank you very much, Mrs. Akiani. Ladies and gentlemen, I will take a photo. Please be ready and give your best smile when I say smile. Okay, I'll start in 1, 2, 3, smile. Okay, good. We're done. Thank you very much.
Thank you, Ibu Igna. Ladies and gentlemen, the photo session concludes our opening ceremony today. Zarkiani Hashim, thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh, and good morning. The next program is plenary session 1 that will be led by a moderator, Bapak Pasjan Satrima Fitrah, PhD. So I invite Bapak Pasjan to take over this session. Thank you.
Hello, thank you very much, Mr. Kiani Hashim.
Okay.
Hello, Vice
sorry,
Rector
Pasjan.
Prof. Amar.
I'm sorry, Pasjan. I'm sorry. I am beginning to leave the international seminar room because I will be participating on the other activity. Please enjoy the seminar. Thank you.
Okay, thank you very much.
Thank
Thank you very much, Prof. Have a nice day.
Okay. Okay, honorable keynote speakers, distinguished guests, participants, committees, and excellencies, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I am Pasjan Satrima Fitra, the moderator of today's first plenary session, and I'm very, very pleased to see you here and welcome you all. So, ladies and gentlemen, as the three of our keynote speakers have already been here with us in the webinar, the first keynote speaker will be delivered by Professor Kim Chong-woong from Gwangju Institute of Science and Technology, South Korea or Korea Republic. Hello, Professor Kim Chong-woong. And also the second speaker will be Dr. Xiaojing Zhou from the University of Newcastle, Australia. Hello, Dr. Xiaojing Zhou. And the last speakers for today's will be delivered by Professor Mada University, Indonesia. So, ladies and gentlemen, before the presentation begins, let me inform you how the presentation will be going on for today's plenary session. So the first one, each keynote speaker will be invited to present the material for 30 minutes. And after all keynote speakers deliver their presentations, then we will move to discussion session. In that session, there will be a question and answer and followed by conclusion. So you can type read out for our honorable speaker.
Okay, so can I start now?
Please wait.
Okay. I cannot hear you. Okay, yeah. Yeah.
Introduce short introduction for Professor Kong Chung Kim. Currently, he's working at School of Earth Sciences and Environmental Engineering in Gwangju Institute of Science and Technology, Republic of Korea, and he completed his PhD from Imperial College London, Center for Environmental Technology, 1993. And currently, he is International Environment Director Institute director there, and also a professor in Gwangju Institute of Science and Technology, Korea. His specialization is environmental geochemistry and health, and also his research areas is about environmental risk assessment, remediation of contaminated radioactive soils, gravity-driven membrane, and for safe drinking water. He has been awarded in Kim Ong-jan Award in 2018 by the Korean Society of Economic and Environmental Geology, and also he has a lot of significant journal publication. The latest one is the bioleaching assessment for nuclear power plants soil contaminated with cobalt and cesium using a SP in 2000 and in liquid US patent number 101757173. Okay, to Professor Kyung Kim, the place is yours.
Okay, thank you for your kind introduction. So I will share the screen. Can you see the slide?
Yes.
Okay. So thank you for your kind invitation, and I'm so honored to have this opportunity or presentation. From the title of conference, so we have many experts from the various fields. Maybe some of you are not familiar with this environmental issue. So I will do my best to present not too long, and I will show many photos and figures to share our previous experience. The title, also I will talk to you very slowly, okay? If it is too slow, let me know. I will speed up, okay? The title is Application of Water Treatment Technology for Climate Change Adaptation. So today I will present several case studies in Pacific Island, including Fiji, Kiribati, Tuvalu. And also we have several research projects. So that is KUNDP project. One of our target country is Indonesia. So I will share the experience in Indonesia to use our water filtration system. So maybe you are not familiar with Gwangju. So all of you only know Seoul and Jeju Island, something. So here you can see this is Seoul, Gwangju, located southwestern part of Korean Peninsula. Many friends confused with Guangzhou in China, but this is Gwangju in Korea. Okay, so this is 200 miles away to south from Seoul. So now we have the fast bullet train. So it takes only 1.5 hours by train from Seoul to Gwangju. So Gwangju is famous for our traditional culture, food, and hope that you can have chance to visit our city, Gwangju. And also you are not familiar with our university. So our university is Gwangju Institute of Science and Technology. This is a research-oriented university supported from Korean government. So most of Korean universities are under Ministry of Education, but only several number, less than 5 universities are under Ministry of Science and Technology. So our university is one of them. So our university is quite young, only 30 years old and small, because this is a research-oriented university. But we are proud of our research excellency. So you are familiar with QS University ranking system. So our university ranks number 4 in the world in terms of citation per faculty in June 2021. So from this figure, you can see that we were 3, 5, 4, 4 within 4 years. So also we are number 1 ranked in the citation per faculty or top business startup, college business startup. So we are emphasizing research and the startup for the business. So now I will start the main topic about the water issue. So this is the slide from the Philippines. Here you can see that in Philippines, from the water and sanitation issue, every day 55 people were killed. So this is real issue. So in Philippines, this village is called Tondo village, but in Philippines, the population is too big and the area is very limited. Some people live in the waste disposal site. So you can guess how bad this sanitation and water in this village. Second one is the climate change impact. So everyone already experienced climate change and global warming something. So because of this climate change, it impacts some tropical, the South Pacific island country. So they are the island. So this Fiji located between Australia and Hawaii. So normally this country, Fiji, did not have tropical cyclone, but because of climate change, they had the tropical cyclone in February 2016. So in this past, you can see the Quelikulo village and Nabulini village, the cyclone passed in the route. Here you can see the photos. This tropical cyclone Winston has got very strong wind. The maximum speed of wind was 300 kilometers per hour. So I'm not sure whether you are familiar with baseball. In the major league, the pitcher throw the ball, the speed is around 150 kilometers. It means that the speed of wind is double of that fastball. So you can guess how strong it is. So all the house were destroyed and all the village were destroyed. So people live in the tent because all the houses were removed. But from this tropical cyclone, so they do not have proper drinking water. Whether we have an earthquake, flooding, or drought, always we do not have safe drinking water. So after this Winston, the number of the waterborne disease has been increased. So it was reported by WHO. So WHO collaborator in Fiji suggests me to bring our water filtration system. So this is the starting point of our project to secure safe drinking water in Pacific Island. Another issue is also climate change. So this is a photograph from Mongolia. So everyone knows that Mongolia is a very dry country. The annual precipitation in Korea is 1,500 millimeters a year, but in Mongolia it's only 300 millimeters a year. It means that they do have less than 1 millimeter of rain a day. So this is a very dry country. So here you can see the desert, Gobi, Altai in Mongolia. Here you can see dry river. But even in this Mongolia, because of climate change, they experience this flooding in Ayalongi. It means that one part is very dry, but next to this part, they have flooding. This is an influence of climate change. Another serious water issue is the groundwater in Mekong River countries. So this is the Mekong River. It starts from China, it passed Myanmar, Laos, Thailand, Cambodia, and Vietnam. But near this Mekong River, there are groundwater. So this arsenic contaminated groundwater the issue was started in early 2000. So because in this Southeast Asian country, the surface water was contaminated. So you can see the contamination of the river water and lake, including Tonle Sap in Cambodia. So international organization, including UNICEF, developed the groundwater for drinking water purpose. But unfortunately, this groundwater was contaminated with arsenic. But actually, the contamination is not the proper word. This is a natural enrichment. So in that area, the groundwater was naturally enriched with arsenic during the formation of aquifer. So we need some water filtration system to remove arsenic. So in arsenic, here you can see the acceptable level of arsenic in drinking water is 10 ppb. But one province in Vietnam, An Giang province, the arsenic level in groundwater is more than 1,400. So this arsenic contamination enrichment is really serious. This is so widely distributed. So here we have many issues of the drinking water, from the climate change or natural formation of aquifer and the industrial activity. So we need the safe drinking water. But in the lab, in many researchers, they develop many novel techniques. But when we apply this technique to the developing country, all the issue is the maintenance. Although we provide the water filtration system, if maintenance is not carried out, maybe the water system will be useless. So we want to develop the water treatment system without any maintenance and low cost. So our technique is using the membrane technique. So membrane is very simple physical separation technique. So here you can see my slide. So in membrane, we have small pore. This is a small hole. So if contaminant is bigger than this hole, it cannot pass. This is quite simple physical separation technique. But this pore size is very small. So if it is nanofiltration, we have the pore 10 to minus 9 meter. So in this slide, you can see the size of contaminant, bacteria, which is related with waterborne disease, virus. Now you know the many Zika virus and many virus and the heavy metals. So depending on the size of contaminant, we can design different type of membrane. And one disadvantage of this technique is the clogging, because we use the physical separation. If contaminants block the hole, maybe we cannot produce water anymore. So to avoid any maintenance, we should overcome this disadvantage. That's why we set up our filter in this vertical system. Also, to operate this membrane system, we need some power. We need electricity. But our system does not use any electricity. The driving force is the gravity. It means that the weight of water can push the water, then we can produce a safe drinking water. So this is one prototype of the system. Inside this, the water filtration, we have this membrane filter. So after I finish the presentation, I will show one video clip how to operate our system. So after we invent this system, we share this system to many countries. This is a curricular village in Fiji. So we visit and we share this system, and we visit Kiribati and even Mongolia. So here you can see one result. In this left-hand side, this is water before filtration. So one parameter of water quality is turbidity. So here you can see very dirty water here. After filtration, we have this clean water. From this slide, you can see one white dot and black dot. It represents the bacteria. After filtration, here you can see very clean water. So this is the one. So this is the result before the treatment. This is result after the treatment. Here you can see before treatment, you can see a lot of bacteria. But after this treatment, you can see the removal of 99.8% of bacteria. Here you can see the number of bacteria, total coliform, E. coli. So most of them are removed after this water filtration system. So we donated this system more than 20 the unit in Fiji. So after we donate Fiji, we were invited by Kiribati. Kiribati is very small island in the South Pacific area. So Kiribati is really small island. The Tuvalu and Kiribati are nowadays very famous because of global warming, climate change. This island will be disappear maybe 50 years later or 70 years later. That's why this is a coral island, so they do not have proper drinking water, so they need our system for safe drinking water. So advantage of our system is, you can see we have our final product of this membrane system. Also, we can bring our filter set only, then we can purchase the container in the supermarket, and we can install our filter inside this, the container. It may take 5 minutes to assemble this system. So we assemble this system and share in Fiji and Kiribati. This is our product. The left-hand side one is a pre-assembled unit. So the filter is inside. So we can send this system, the volume is 40 liter. So the flow rate is the 15 liter per hour. So this small system is designed for the family. One small family can use that. This is another type. We can purchase local container. Inside this container, we can install the membrane set. You can see this volume. And this is the photo in Kiribati. Kiribati is a coral island. They drink this very shallow water. So we donate our system, and they collect the water using this bucket, and they pour it, and we can filter. So the one is the result of raw water before filtration. You can see a lot of aerobic bacteria and coliform and E. coli. But after filter, here you can see very clean water. From this result, you can see the reduction of the bacteria by our system. So when we share our small scale system, we have some demand and request from the Kiribati government. Kiribati is very dry country. So they store rainwater for drinking purpose because they have a longer period of dry season. But they ask us to install membrane inside this tank. So we need to design bigger size of tank, the membrane into this tank. The size of this tank is 5 tons, 7 tons, 10 tons. So this water storage tank is used for the village. So we install our bigger size membrane inside this tank. So this is a tank. This is a Ministry of Environment in Tuvalu. And so inside this tank, our experts jump in, then they install this tank. So you can see how dirty this source water is. Also, we share this system to Tonga and many islands in Pacific region. And we visited one more time to provide our filtration system into this bigger size tank. Here you can see inside this tank, they never cleaned this tank. So the inside this tank is really contaminated. But after we install this bigger size tank, they have safe drinking water. So here you can see the result. This water is the before treatment. Before treatment, you can see a lot of bacteria. But after we treat the water using our bigger size membrane, here you can see the removal of all the bacteria. So still they have safe drinking water from the water storage tank in the village. So this is our final product. So we will produce this small scale, the water treatment system. We can call them gravity driven membrane system. So we can call them GDM, means that we do not need any electricity. we need only the gravity, the weight of water. And this is very effective for bacteria. So if we have only bacteria, if we have the bacteria or waterborne disease, so we can use this system. We can use 99.99% of bacteria, and no maintenance is needed. So we can guarantee at least 10 years without any treatment. So we test our system more than 3 years, still it works quite well. But to enhance our efficiency, we try to use the solar panel to monitor water quality. This is an ongoing project. We invented different type of the water treatment system. As you can see, the size of the heavy metal is smaller than bacteria and virus. So arsenic is very small, the iron. So we need nanofiltration. So we invent this kind of nanofiltration. As you can expect, nanofiltration pore size is very small. So we need driving force. So we, instead of using electricity, we can use the hand pump or pedal. So we can design different type of water treatment system for removal of arsenic in groundwater. And finally, I will introduce our ongoing project, K-UNDP project. This is funded from UNDP. Well, this is a second stage of project from 2019 to this year. So we provide a sustainable drinking water using gravity-driven membrane to Cambodia and Indonesia. Professor Yani Sudiani at LIPI is our collaborator in this project in Indonesia. So this is our target area in Indonesia. So I'm sorry, my pronunciation is not good, but this is in Sukabumi area. So here you can see we provide our system to the schools. So we provide our system to this school in Indonesia. The production rate is 30 liters per hour. So all of them are drinking purpose. So this is a photo in Indonesia. Inside this bigger size tank, we insert GDM and students can drink this water. Here you can see the water. We have safe drinking water from this system. And so this is the before treatment, after treatment. So we provide many systems to Indonesia. So I will skip. So also we train the community people about the importance of water and sanitation. So this project will be successfully finished by the end of this year. This is a case in Cambodia, then I will skip. And before I finish, I will share one video clip to show how water was filtered by our GDM system. So I will share the different video. Okay. 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 Give me 1 second. Okay. Sorry for that. Okay. I should open the file. Okay. Okay. Okay, so this is the water filtration system, and we install filter inside this tank. Can you see the slide? Okay, can you see the video clip?
Yes.
Yeah, okay, so I will turn on. So we have clean water inside this tank. We have the filter, but you can see how dirty the source water is. This dirty water will be clean like that. Okay, this is the family size water filtration system. So without any electricity, we can produce, and I drank that water more than 100 times. So this is a good way to demonstrate. So still I'm okay. So I hope that you can trust our water filtration system. So Terry McCarthy, thank you for your attention. Thank you.
Thank you very much, Professor Kim, for giving us such an informative and interesting presentation. Ladies and gentlemen, before we move to question and answer session, I would like to let our second speaker as scheduled, Dr. Kuat. Professor Kuat, are you with us now? Sorry, Professor Kuat Triana. Maybe still no response from Professor Kuat Triana. So I would like ask permission to Dr. Xiao Jingzhou to present, to change the schedule to be the second keynote speaker while waiting for Professor Kuat Triana.
I think
okay for you?
I think when you first introduced, you put me as the second one to talk. That's
Yeah,
fine.
yeah. Okay. Before we start the presentation, let me give you a short introduction about Dr. Xiao Jingzhou. Let me share my screen first. Okay, Dr. Zhou is a senior lecturer at the University of Newcastle, New South Wales, Australia. She obtained her PhD in chemistry in 2006 from University of Waterloo, Ontario, Canada, and worked in the research field of organosilicon surface interface. Moved to Australia in 2006 and now work as a research fellow under the supervision of Professor Michelle Simmons. She joined a newly established Priority Research Center for Organic Electronics at the University of Newcastle. And until now, she has been working in the fields of novel organic semiconductors, organic electronics for sensing and photovoltaic applications. Now, allow me to welcome the speaker, Dr. Xiao Jingzhou, to deliver his presentation. Dr. Xiao Jing, the time is yours.
Thank you, moderator. Thank you for your kind introduction. And thanks, Professor Kim, for your wonderful work to solve, environment problem for, for people living in the island. I can see how important to be able to drinking clean water. And when you have the pictures with those well, I remember when I grew up in China, we also have those well as well. And so we put the bucket into the well and then take out the drinking water because at the time my family doesn't have running water. So at one time, and my mother drilled a very deep well. And what we found later on is that they got very high calcium level in the water. So when my family tried to make tofu, and it doesn't work. So the tofu just magically disappeared from somewhere. And my mother didn't know why. And then later on, when I went to university, I actually took this water and did the chemical analysis. So it's very interesting work about that. Now, coming to my research area, let me just share my screen first. All right. Okay, so, right. Where is Newcastle? So I went to Canada, yeah, about 2001, and get my PhD from University of Waterloo. And so since 2006, and I moved to Australia, and I work at University of New South Wales for about a year, and then just moved to Newcastle. So where is Newcastle? Yeah, Australia. Now, if we look at the Google map, right? So you look at Google map, and you see Australia is on the bottom corner. Where when I flew from Canada to Australia, and because the time I cannot stop by US, so I have to fly all the way back to China and then from China to Australia. So it took me about almost 2 days to actually arrive, from Canada to Australia. Now from China to Australia, you can see here we are close to South Korea, Japan, and Indonesia is in the middle. Yeah, so and then you got Singapore. And a lot of times when I fly from Australia to China, I'll stop in Singapore. So as you can see, we are a really family here on the left corner on the east. Yeah. So this wonderful conference has actually kind of connected us in this region, in Pacific region. And so we kind of share our research experience with our colleagues in a different field about environmental, about health. So it's very good opportunity for me to share my research with you guys as well. Now we look a little further in terms of Newcastle. Probably most of you guys know Sydney, right? You can see we are on the east coast. So if here is Sydney, and Newcastle is about 200 kilometers away from Sydney. So it's about 3 hours in terms of driving. Yeah. So we are close, but we are in a regional center in terms of Newcastle. So this university is a kind of a regional university relative to universities in Sydney, in Melbourne, while in a small scale. And most of our undergraduates are domestic students from regional New South Wales. And so what I remember when I first started work at the Newcastle, I hardly see any international students, but in the past 10 or 15 years, we see more and more international students coming even to Newcastle as well. So it's globalization, yeah. So and then infiltration to deeper and deeper in the regional Australia. Now Newcastle is really a beautiful city. So Newcastle, and that's why actually I like to move to Newcastle because it's really beautiful when I visit here. So it's really a town, or around the Hunter River, around the ocean. So we got beautiful beaches and beautiful harbors, and we have really nice beaches in a summer day. You can just go and dive into beach, dive into oceans quite nicely. And we also have a lot of beautiful ocean baths. You can actually, if you don't like ocean, you can just actually take it in a swim. Yeah, you can swim in a swimming pool. So this beautiful Merriweather baths just near the ocean. So when you swim, you can see the bath water basically connected with the ocean water. It's really beautiful. So if you guys want to, would like to visit, let me know. Yeah, I can host you, drive you around a little bit to see Newcastle in Australia in general. Right? Okay, so University of Newcastle and set up a few priority research center around 2006, 2007. And that's the time when I had a job offer to come in and join the newly established priority research center for organic electronics. And so in the organic electronics center, and we have a few focuses in terms of research thing. And the most well established one is the printing the solar. Yeah, so this part, and we have the rail to rail solar cell printing, and we also installed 300 meters square in a warehouse roof, and for just for a middle test, just for a test. That's we already done that like in the past 3 years. And the second thing for our center is the biosensor and bioelectronics. So we also focus on to develop your product interests health and in improving people's health, living quality of living. Yeah. We also have other small area like artificial retina, and we also have area where we can develop novel new microscope, be able to measure softer material and other medical physics field as well. But for today, I will mainly focus on to the biosensor. Yeah, so I would talk a little bit about the work I have done in the past years in the biosensor field. And in particular, this work I'm going to talk about is a work in the past 3 years when I first started, when I had my sabbatical in 2018. So 2018, I had my sabbatical. So I actually flew back to Canada and then to work with my old PhD lab, and where I wanted to be able to somehow find a new pathway and to be able to develop a new pathway where we can detect saliva range glucose sensor. So that was collaboration with Professor Kenton Ong at the University of Waterloo. So when there was second half of year 2018, so when I coming back and I continue work on with them as well. And so this research, I needed to introduce a little bit of background, yeah, because at the Newcastle, and since I joined the group, and I was leading on a area, and we try to use organic thin film transistor for biosensor application, right? So basically, we're building a transistor. Yeah. So first of all, we need to understand the transistor first, and then the good thing about transistor is that the transistor can amplify signals, right? And so if a transistor can amplify signal, if we have very small biosensing signal, we can amplify that. So intuitively, this is a good sensing application, right? So that's why we started back in really 2006 and 2007. And so since then, we can continue to develop, and we attract quite a few industrial funding, and we had a collaboration with the South Africa Explosive. So we actually helped them develop a disposable explosive sensors. But more importantly, around 2013, we attract a really good investment, venture capital from a group called IQ3, and this is a venture capital company. They try to looking for startups, right? So they invest about over $5 billion in 5 years, and the whole reason is we really wanted to develop a printable glucose sensor, right? So printable saliva glucose sensor, that's our main goal, and we have a few stages of development in terms of this research, right? So if we go back to look at our the device structure at the center when we first started. So we start with the glucose. We want to have a glucose sensor. So you want to detect glucose. For most people, if you have if you have a diabetes, you have to measure your glucose concentration a few times a day, right? So for most of the diabetes patients, when you measure your glucose concentration, you measure in blood, right? So which means the patient has to stop themselves at the finger and get a few drops of blood, and then you measure your concentration of your glucose. So you monitor your glucose concentration in your blood in order to keep in the acceptable level, right? So that's very important. So our goal is that if we can develop a glucose sensor, use our salivas instead of use blood, it'll be much more you'll be much more attractive and also less painful, right? So if you have to stuck your finger every day a few times, it's painful. And so our goal was that use the existing structure we developed for transistors. So if we are looking at a transistor structure, right? So you normally have this 3-terminal device. So you have a drain, we call drain, we can have source, we got a gate, we got 3-terminal devices, right? So we try to use this to detect the current, which promoted by glucooxidase. This is the glucooxidase, is the enzyme, right? So glucooxidase and will promote glucose, and then you form this acidic species, and then it can get measured under a small voltage, right? So that was our goal to do that. Now, if we wanted to be able to develop this type of saliva-based glucose sensor, and we know that we need to measure the glucose sensor region roughly about a few micromole to a few hundred micromole, that's our normal range. If you don't have diabetes, if you are a normal person, that's the range of a normal person should go, right? So if we can measure in this range of our, in the saliva, if we can measure the glucose in this region, and so if we are out of this region of the glucose concentration, that means you will have problem with your glucose concentration. You need to somehow adjust. If it's too low or too high, both are not good, right? So when we had a few years ago on this pathway, and we have quite a success in terms of measuring into a tens of micromoles. Now, when we come down into the few micromoles, that's kind of we're pushing to the limit, and we found a very hard to find the reproducible and reliable data at the lower range of the saliva glucose concentration. So that's why when I first went to Canada, so I like to find a new pathway. Yeah. So when you measure the glucose with enzyme-based method, right? You need to have glucooxidase, which is your enzyme to promote the reaction, right? And that way, and the response of the reaction is, especially when you are in a solid material, it's very slow. So response is, they have a quite long delay process, and also the saturation also takes quite long to reach saturation, right? So this is some limitation on the method. So I thought maybe I can find a new pathway where maybe we don't need enzyme in our device, right? If we don't need enzyme, we can have it chemically promote this reaction. Maybe there is other alternative way, can be faster and more accurate, right? So I was looking at the literature at this time, and there were a few literatures pumped up about you can use copper nanoparticle or copper oxide nanoparticle or cuprous copper particle in graphene, in carbon nanotube. So a whole bunch of research study on that part, but there is no any kind of conclusive determination about really how this method can get used to develop glucose sensor type of research group, right? So I saw because in my PhD I did quite a lot of work in terms of electrochemistry. So I know that I can pick up this work quite quickly, right? So if we look at the new way, where if you don't have the enzyme, if we don't need glucooxidase, and instead we can use copper, or can use cuprous copper, we can use copper species. Now for copper species, you can, when you oxidize the copper species, and you can form copper oxide, and you can form copper hydroxide, and then from copper hydroxide, can I put my laser point? So if we have copper oxide, and copper oxide can get a hydrolysis and form copper oxide hydroxide, yeah. And this copper oxide hydroxide is kind of in a metal stable states, and it like to oxidize glucose, and that's why you form glucolic acid, right? So this reaction is very crucial. That is how we measure glucose concentration. So if you have this interaction, if you have this step, and you can measure the current from this electron, right? And we can measure current, and in that case, we can use as our sensor elements to measure glucose concentration. So I did a first trial, and this is relatively a simple experiment, and I have really nice, response at the tens, even a few micromole concentration. So I was very excited. So I carry on with this work for 6 months, basically, and to know what is really going on in terms of the inside of this experiment. So if I'm looking back, so how really we prepare the whole sensor, right? Sensor. So actually they involve 3 steps. So the step 1 is actually you need to prepare copper nanoparticles. And so if you prepare copper nanoparticles in the electrochemistry, you need the electrode. Yeah, your electrode. And at the time, I was doing research also in parallel in graphene as well. So we were actually grow graphene as electrode, as transparent electrode for solar cells. So at the time, I thought, you know what, graphene actually is quite a good electrode, because we can actually grow graphene and make it very conductive, and you can actually, and it's flexible, and you can cut to any size you like. So we actually can use graphene as our electrode to prepare the copper nanoparticles, and that's what I did. So we prepare the graphene electrode, and it's very conductive. So we won't talk about graphene, it's not single layer graphene. It's really a multiple, graphite, but highly orientated, right? So we can prepare this graphene about 25 micron in our size, and then the heat resistance go down to really in a million per square. So it's really conductive, almost like metal, right? And so you can cut it to any size you like, and then we put it into electrochemistry station. So the graphene will be my working electrode, right? And then I will have the platinum as my counter electrode, and then silver chloride as my reference electrode. So you have 3 electrode working chemical workstation. And so I can use this to prepare copper nanoparticles. And then before we go to talk about the biosensor applications, I was interested in what kind of copper nanoparticle I'm making on the graphene electrode, right? So after the electrochemistry, I actually went to do a scanning electron microscope. And I also want to know, is that copper, metallic copper, or is copper oxide? So I was very interested. So I also did the glancing incidence XRD, X-ray diffraction, right? And also, if you want to know the chemical species of your copper nanoparticle, I also did the X-ray photoelectrospectroscopy, and also we can sputter down and look at the nanoparticle, what happened on the surface, what happened inside the nanoparticle. So we do depth profiling from the XPS as well. And in the group, they also have the helium ion microscope. So this helium ion microscope is not many labs have this facility. So I was also be able to use this facility to look at the copper nanoparticles we're making. So we talk about nanoparticle, we don't know really specifically about the nanoparticle until we have done all the measurement. Yeah. So then we have understand so before, when we deposit nanoparticles, you kind of needed to know what kind of the voltage, right? If you want to have constant potential, and then you need to know what kind of voltage do you pick to do the deposit, right? Because you have copper ion. Copper ion has to be reduced into some kind of copper particle onto your electrode. So when we do a cyclonic volumetry and we scan the graphene, right? And in the solution, yeah, so after we've done this, we kind of see the, in the reduction, there are two peaks in the reduction side. So the peak A is really just right after 0 volt, yeah? And then there's another peak, which is about minus 0.3 volts. So for copper, when you reduced, you probably go through copper 2, from copper 2 plus to copper 1 plus to copper metallic copper, right? So which makes sense. You have 2 steps in the reduction, in the direction of reduction, right? So I thought, okay, so that means if I want to make copper, I make a metallic copper nanoparticles, so I needed to go a little bit beyond minus 0.3 volts. So when we use overpotential, right? So overpotential, where you form 3-dimensional particles, it's the clinically more favorable mechanism, right? So then I went and did a deposition with 2 steps. So I actually used 2 voltage and kept them at a different time, right? So the first one I kept about minus 1 volt, so for 10 seconds quickly, yeah. And then I cut down into minus 0.4 volts, about 100 seconds. So hopefully we can grow something. And then I did SEM. So we can see for this beautiful like cubic particles everywhere, but we also see some of the big chunks of copper particles. Yeah. So I was very curious about how we form the small particles and the big particles in this bimodal formation. Yeah. And with the XRD, we can see that we have we have a copper, metallic copper, we also have copper 1 plus, we call the cuprous copper oxide. Yeah. So we got these two types of XRD measurement. Is that, and now I was wondering, is one type of copper morphology contribute to metallic and other type contribute to cuprous copper, or they are mixed into each particle, right? And theoretically, if we want to have a good sensor, we want to make small particles, because small particles, you're going to have larger surface to volume ratio, right? You have more sensitivity if we are talking about the catalyst, right? So that's why our goal is to actually get rid of the big chunk, right? So that's what we did. So later on, we actually changed a little bit about the electrolyte, and we also changed we use a different type of a copper ion. So instead of a copper chloride, we use copper sulfate, and we use sodium perchloride as our electrolyte. And then by changing the different overpotential, and we now be able to control the size of the cubic, right? So the size of the cubic, and we can eliminate this big chunk which is intuitively not good, right? So we can actually just produce the small cubics, and then by control the different overpotential, you can change the size of the cubic as well, which is very important to be able to control the shape and the size when you do electrochemistry, right? And so then we did a more careful study on XRD, and we found the same phenomenon. Yeah, even with this only cubic type of nanoparticle, we also see both of the metallic copper. Yeah, we also see cuprous copper as well. So we got 2 types of the copper oxidation states. You got metallic, you got copper 1 plus. Yeah. So now our question is that how is those 2 copper mixing? Are we talking about each individually cubic? They are made of 2 types of material. Are we talking about they're just mixing somehow? Because both metallic copper is an FCC structure, right? Which means that favorably formed cubic. And you also have cuprous copper, is slightly lattice constant, but you also have a FCC structure as well, right? So which means both of them can form cubic structure, right? And so we want to find out chemically how is those 2 copper oxidation states and exist in the different nanoparticles, right? So in that case, and okay, so I'm coming to really close to my time. Is that? No, 13. Okay. So then we did a chemical analysis. We did the X-ray. We did X-ray photoelectron spectroscopy, and so what we found is that we have copper, we have copper, and we also, with XPS, you can do the OJ, and you can distinguish between copper and the copper oxides. And we know that in our nanoparticles, we got both type of the chemical states. But as we are sputtering, as we are profiling, poaching the core, and we see and more metallic. So that's what we get into this conclusion. We have a core shell structure. So that's why we also convert this with the helium ion microscope. So as we use helium beam to strip down this particle, and you can see the core is got higher density than the surrounding, right? So this came to a proposal, and we said that we have a metallic core, and we have the copper in a shell, and of course when you put it into the sodium oxide, and you can have the copper oxide as well, got very thin skin outside, and it can quickly get it sputtered down, right? So we actually formed this very good core shell structure. So then if we have this cubic copper, but when you oxidize it, right, when you put the sodium hydroxide, you form this really clapped cubic structure, and this is very good for sensor, the FL sensor, because now you actually enlarge the surface to you enlarge your surface area, right? So, and then we did the measurement about, and then we measure the glucose sensor testing on this one. And so we also did a different type of combination as well. So we did the graphene only, and you have copper and graphene, and you have the cuprous copper on graphene, which is this cubic structure. And we also compared with the glucooxidase enzyme based as well. So what we found that the cuprous copper cubic structure give you a higher sensitivity, which allow you to measure basically in a glucose range. You can see we in a saliva glucose range, we have highly linear in terms of the calibration curve. And we also did the interference study, and we found the glucose is most sensitive to in terms of in this setup, right? So that's kind of we also did the comparison with other groups' work as well. So this is a carry on. It's quite nicely, and so next step is to be able to really go from a small device, a lab device, to a disposable glucose sensor, right? So we actually did have to change the configuration, because you can no longer afford to use platinum as your counter electrodes, and your reference also has to be changed. So later on, when we actually modified the setup to including a silver as our reference, and the another strip of graphene as our counter electrode, and the cuprous copper, that's our working electrode. So we actually be able to do put a PDM as well, right? And then you can put your drops of glucose drops in there, and then we can measure our disposable glucose sensor testing, which is worked quite well in down to a few micromole, in a range we're interested, where we have a high linear response from our sensor to glucose concentration. So that's it, kind of what we that's where we are. So in conclusion, and we used a non-enzymatic way and to measure the glucose concentration in a saliva range. And this is quite exciting opportunity for us to be able to implement into our IQ3 project. That was our goal, and to be able to actually make a commercially viable devices for people with diabetes. So hopefully in the near future, and this can come and you can buy our glucose sensor from the Young Farmer Shelf. So thank you very much. I think I'm going just a little bit over time. Yeah, so that's so good. Thank you very much.
Okay, thank you very much, Dr. Xiaojing So, for such informative presentation. Very interesting. So we can detect glucose in saliva by using copper-based nanoparticle and graphene. It is very interesting because some people are afraid of syringe. So they don't have to take our blood because some people are afraid of syringe. So just take the saliva and detect the glucose. Okay, ladies and gentlemen, before we move to the next keynote speakers, it's a gently reminder for you to fill the attendance list. We have shared the attendance list in the chat. So please feel free to fill the attendance list. Okay, once again, thank you very much to Dr. Xiaojing So. Next, we move to the last keynote speakers for today's plenary session. Professor Kuat Triana. Hello, Professor Kuat Triana.
Hello, good morning.
Good morning. How are you?
I'm fine, thank you.
Okay, because Professor Kuat Triana already joined us here today, so let me introduce him a little before we start the presentation. This way. Okay, Professor Dr. Kuat Triana is head of the Department of Physics in Faculty of Mathematics and Natural Science, University Gadjah Mada, or Gadjah Mada University. He completed his Doctor of Engineering at Department of Applied Science and Materials, graduate of Engineering Science in Kyushu University, Japan in 2004. He also currently a principal investigator about development of electronic nodes for fast and non-invasive diagnosis of SARS-CoV-2 COVID-19 based on volatile organic compounds of breath. His recent paper about gas and humidity sensing with quartz crystal microbalance coated with graphene-based materials in 2021. He has a lot of publication. He has a lot of patents as well. The latest one is composition of MD1 to FT103 metal oxide alloy and method of preparation, and also light emitting diode light source instrument for photodynamic inactivation of pathogenic bacteria. Okay, thank you for your kind attention for the short introduction. So, Professor Kuat Triana, the time is yours.
Okay, thank you very much, Mr. Moderator. I would like to share my presentation first. Can you see here my presentation?
Yes, it's visible.
Okay. Let me prepare. Okay. Good morning, ladies and gentlemen. First of all, I would like to thank to the moderators that introducing me to the audience. I am Kuat Triana from Department of Physics, Universitas Gadjah Mada. I'm also founder of the PT Nanoscience Instrument Indonesia. And today, I'm very happy. And so I would like to thank also to the organizing committee because I have an opportunity to share one of our projects about the electronic tongue. So the title of my presentation today is about the recent progress of the development and application of electronic tongues in Universitas Gadjah Mada. hopefully after my presentation, I want to have collaboration with many researchers among us, including from Indonesia and also from abroad if it's possible. So we are open to make a collaboration in this case. We thanks also Ibu Trikan. I think she present today. So before continuing my talk, I would like to share about the outline of my talk. I want to talk about the electronic tongue working principles, and then continue with the test evaluation, continue with the test center development, and finally, I would like to share about the next commercial product. So here, I don't want to share you about the real research like the previous key speakers, but I just want to show you about our activity. So hopefully we can really join together to make a collaboration to have research development and some application. Okay, I would like to start with introducing my city. Yogyakarta is like another place of tourism destination. Yogyakarta is very famous, especially before pandemic of COVID-19. So it is located in the middle of the center of Java. Yogyakarta also close with the Borobudur Temple. This is the biggest Buddhism temple in the world, and also we are closing with the Prambanan Temple. It's also the interesting destination of all of you, I think. And this one is our campus, Zamada campus. This, I think UGM is the biggest university based on a number of students. So please welcome to Yogyakarta next time and contact me when we can talk together and maybe we can make some activities together and so on. So this is an introduction of our city of Yogyakarta, Indonesia. So I always like to start with what is the working principle of the electronic tongue. Like our tongue here, there's a sample, for example, here. I think our tongue can work properly, and start from our tongue, and then testing, and then our brain is working, and then classification. Here in number 5, we start from the detection using sensor array. We don't use the single sensor, but we use the sensor array with global selectivity. So here we don't measure a single value of the response of the sensor, but we make a pattern for specific sample. So after sensing, then we make analysis, for example, using artificial intelligence, and then we make a classification, for example, saltiness, sweetness, bitterness, and so on. So it is similar to our tongue. So the electronic tongue use geometric methods and also maybe artificial intelligence to achieve a similar global discriminate identity of quantity of the sample. And this is a very simple basic principle of electronic tongue in general. So we learned from the firstly of the electronic tongue concept. This is in this year. This concept is still very simple here. And then continue with the benchtop experimental test sensing. I think then continue with the global market of commercialization of the electronic tongue here. The process also still very high, and a lot of researchers then develop the hybrid electronic tongue and miniaturization of the electronic tongue. It means the make a more mobile of the device. And right now, AI-assisted portable electronics also possible in markets. So here I want to share what and our activity for the development of the electronic tongues. This is the application of electronic, for example, in the track-related field, for example, for formulation studies like formulation, consistency of and uniformity of track, for example, and also maybe for identification of flavor, taste, and odor masking, and so on. But electronic tongue is also possible to be used for quality control, like the stability studies, detection of alteration, and also drug impurities, drug product batch comparison, and so on. We use also possible to use electronic tongue for dissolution testing, and of course also for perspective, like for synthesis and reactors, drug discovery, and then test masking, and so on. So a lot of application of electronic tongues, and it is possible to develop in our laboratory because the production is not so complicated. It is very simple. So I want to show you also the commercial electronic tongue in market. I think the first electronic tongue that became available in the market was constructed by Professor Toko and co-workers in Kyushu University in Japan when I was studying in Japan, but my topic is not about the electronic tongue. This is different from the my PhD study in Japan. So this is a commercial one of electronic tongue. So it is also possible, but maybe the price is still very, very high for us. So that's why we are developing the our own instrument, including the sensors. We start from the low-cost sensor array like this. Compared to the previous one, this one is one sensor. This is only one sensor. Yeah, this one only one sensor. So for making 10 sensors, for example, the area should be very big like this. But this is a small one. We start learn from the college in Portugal. This is a very simple, just still about the PCB board with the scheme of a circuit of 10 sensor with epoxy conductive silver paste in one side, and then protected with the acrylic resin for waterproofing. It is very simple, and we start making this kind of the sensor is collaboration with our college in Portugal. Another technique is also possible, but maybe it's not good enough. And this one is also another an example when we are making a sensor array, and the black dot is lipid sensor membrane like this one. This is a lipid sensor membrane. It is consisted of plasticizer, combination between plasticizer, this polymer, and then combined with the lipid for tailor the sensitivity to some taste, and then compared to the reference electrode. So we can collect the data in the case of a sensor array, not in a single sensor. This is an example of our system also similar to this sensing. This is the sensing, this is the response of the sensors. For example, if we have 10 sensors, then we have 10 lines like this. So from here, we can make a metric, for example, and then we analyze using geometric tools. And finally, we make a decision in the end of this analysis. Like this, it is also possible to make not only for qualitative approach, but we also possible to have a quantitative approach. For example, if we change from the this is a qualitative approach using, for example, principal component analysis, and then we are using also the linear characteristic analysis. This is supervised techniques. That is a non-supervised technique. But we also possible to make a prediction between experimental values and the predicted value. Experimental value is the standard value of the sample. So after training of the student system, the electronic tongue combined with the chemometric system can predict the quantity of the content of the test in the samples. So this is a qualitative and quantitative processes are also possible. And this is our first low-cost electronic tank. This is our first project with our college in Portugal. We use the similar sensor system, but the system is still more simple compared to the previous one. So in this case, we are able to distinguish between, for example, this is a trend data, this is test data, trend data for fermented milk, and this is the natural milk and ultra high temperature milk. So it can be separated easily. This is our first electronic tank in publication. So then we developed another application for fast authentication of the Indonesian seafood coffee, or we call a kopi luwak. You know that the price of the kopi luwak is very high compared to another high grade coffee, for example, Arabica coffee bean. So it is interesting because we can collect many type of the kopi luwak from many plantation and from many industry, and also the 5-grade Arabic coffee from many plantation and also from many industries. So after that, we test using the electronic tank like here, and the result is like this. So we compare kopi luwak to another sample is also separated easily. So we analyze more analysis using the linear discriminant analysis. The system can separate perfectly between the luwak coffee, this area, and the bottom area is the non-luwak coffee. So it's very simple to make a detection of the sample. So we conclude from this experiment that the accuracy of the system can be almost 100% in this case, after cross-validation using the standard of K-fold cross-validation system. Another application of our electronic tank is also for fast authentication of Zamzam water using our system, the same system. This is a small system one, and it's also possible to differentiate, or we can make an authentication method. I mean that, as you know, that the Zamzam water is very high in price compared to another mineral water, and or even drinking water. So we try to collect many Zamzam water from many places in around Yogyakarta, and we also collect many. This is one branch of the mineral water, and then there's many brands. So you can see here that one brand is more consistent rather than many brands that maybe the price is lower compared to the M1s. And T is the distillated water. So totally different between Zamzam and mineral water and also the distilled water. So it is also interesting for us, and that's why we can separate it almost 100% just using two sensors, sensor number 11 and sensor number 15. So this is an example. This is a this one is non-Zamzam, and this one is Zamzam. This is also possible to make a separation. We add another sample. This is the distilled water, so we can also separate it perfectly between three types of samples. So another application, we try to make detection of spinal muscular atrophy. I mean, this is an application of a medical application. I'm not sure about the medical term in this case, but our partner from the Faculty of Medical in UKM is also working together, and we are developed to detect the plasma of the blood of the patient. So right now it's still in progress. So we hope that next year this result will be complete, and we will make another standard testing of diagnostic. And okay, we would like to also to show you the next commercial products that we are developing in our laboratory first. Then we make more analysis and also more development in our industry. So this is an electronic tank. I show you that this type of electronic is rather bit different from the previous one. Why? Because we are using a lot of sensor here, about 28 sensor with different sensitivity and different characteristic to the samples. So using the 28 sensors, we hope that we can use the electronic tank for the research application, not for application specific for some sample, for example. Because after training of the system, then we can make optimization of the number of sensors. The sensor that contribute significantly to the discrimination between a different sample, then we can choose. Then another, the less contribution can be deleted. So, like in our previous application, from the 28 sensor, we just take the sensor number 11 and number 50. We optimize using, for example, genetic algorithm and also random forest algorithm and many type of algorithm that we can use for optimization of the number of sensors. So basically, when we already choose the two sensors, and then for application in this case, for example, just for application for some water detection, then we just need only two sensors, sensor number 11 and sensor number 15. Like so, then we also developed another device we call the eNose-G. This is the electronic nose for dedicated for detection of Ganoderma infection of the palm oil plantation. This is also a problem in Indonesia and even from Malaysia, Thailand, and many countries who have palm plantation. Yeah, this is also possible for good products in the future. We also in this year finalized the prototype of the electronic eyes. This is the microscope without lens. So we sometimes we call the lensless or lens-free electronic eyes, combined with artificial intelligence also. So this one is a demonstration of our product and electronic tank completed with our samples. So this is can easy to apply. Just make a adjustment of the time when ranging of the sensor, so it can be helpful for researchers and also application in some industry. We have started to work together with some industry, especially for detecting taste of the food product. So another application is also possible. So I invite all of you, and especially from Indonesia, to join us to use this kind of machine to detect some, for example, alert detection, and maybe some another application of alert application, another control. This is just an example of our system right now. I want to give you another product like this. Yeah, this one is, as I mentioned before, this is the lens-free holographic microscopy. We published in this year, in February 2021. We are working together between the research in Indonesia and in Germany. So we developed the prototype in Indonesia, and we tested and put in Germany and Indonesia. And then we develop also not only the hardware, but we are also developing the software for artificial intelligence. Why? Because this system is like microscope, a small microscope, but we want to make a powerful microscope with artificial intelligence, like the part of this figure. This is the cell tracking using this machine, and this small machine, and then also we can long-term cell observation and cell sorting, for example, for classification is also possible. For example, if we want to detect directly the bacteria, for example, not cell, but the bacteria of tuberculosis, for example, we are now trying to make a training in the artificial intelligence. So hopefully this next year we will release this product to the market, especially in Indonesia and many countries. And this is a electronic nose for Ganoderma detection. We apply in the field. This is the palm oil. For example, we just make analysis using a very small first prototype of NOSG, like this one. But right now we make a smaller one, like a mobile system connected to the mobile phone, and then we analyze directly in the field. So if the plants and the palm oil plant is infected by the Ganoderma, then we can make a mark, and another treatment can be given in the plants. So it is very interesting also because Indonesia is #1 in palm oil plantation. Okay, this is another our story about the electronic nose for detection of COVID-19 right now. Even in transportation is still stopped right now because of some reason, especially for the business reason and also for the political issue. But in the industry and also in the hospital, a lot of our machines still in operation. So this is an example of our commercial product in electronic nose. And then the product is like this. This is a Genus C19 for detecting the COVID-19 just from the breath of the patient. Combined with the artificial intelligence, we can detect whether the patient is positive or negative of COVID just into less than 5 minutes. So it is very fast and without any or invasive treatment. So it's very easy to detect the COVID-19. Right now, because of mutation of the coronavirus, then we still in a struggle to make a new training by collecting first the response of the sensors of the Genus C19 to a lot of people who detecting with the new variant of virus. So still in struggle once. And here I want to show you, just introduce our industry. This is still a new industry to support our activity in laboratory. So some problem in our country, for example, Indonesia, for example, especially in my university, when we complete the research in laboratory, then we still stop. No production, just publication. So publication is also very important. But after that, we stood thinking about the mass production and apply to the society, for example. And this is like a bridging between the researchers and the businessmen. So we need the nanoscience industry. This is some product, as I mentioned before, electronic tongue, electronic nose chip, or Ganoderma, and also lens eyes. Another partner, we also working together between Universitas Gadjah Mada and another industry in Indonesia. And also we are working together now with the PETCAN diagnostic technology in the UK right now to develop some another detection techniques or machine, or maybe the detection method for some application in medical. So this is the innovation in our industry for medical application. We are developing now. This year, we also start to develop the what we call the microfluidic based biosensor for dengue infection. So it's also a problem in Indonesia. And we also working with the food industry and halal detection and veterinary application for detection of bacteria and for not human but for animal, and also quality control in industry and drug and biology. I think this is all my presentation, shorter than the 30 minutes, I think, and I close my presentation and back to the moderator. Thank you very much. I close to the presentation.
Thank you very much, Professor Kuat Triana. A very, very interesting presentation. So the electronic tongue to detect chemical compound such as the type of milk, the type of coffee, and also the types of mineral waters. So also Professor Kuat has presented to us the eNose to detect Ganoderma, and the late eNose is the GNose C19 to detect COVID-19 and still develop due to the mutation of the virus. And also the lensless eye. Oh, this lensless eye, very interesting. So because all of the keynote speakers have presented their interesting presentation, so now we move to discussion session. As we can see from here, I can see from here some attendees already asked the question from the Q&A, and also has been answered by Professor Chong-Woong Kim, actively answered the question by typing the answer in the Q&A. Thank you very much, Professor Chong-Woong Kim. So if any attendees has other question, so you can raise your hand and we will give you permission to speak if you want to ask the question orally. But if you would like to ask the question by Q&A, I will read for you. Okay, maybe there is still an unanswered question from Muhammad Yudhistira Aziz. So the question to Professor, yeah, Professor Chung already answered, but maybe from Dr. Xiao Jingzhou.
Yep, I can answer the question probably just orally and type my answers because it's quite long.
Yes.
So the question from Muhammad is that your working electrode, can we use working electrode with carbon paste electrode? The answer is yes. We also tried. Now the sensor itself, the whole point is that the sensor, the sensitivity is dependent on the size and the shape of the nanoparticle, right? So when you change the electrode, especially you use a carbon paste, so it's amorphous, and that means your nanoparticle won't just on the surface. It's going to be diffused into the pore inside your paste. That's why we prefer not to use carbon paste. But when we are in the printing stage, so we actually like to use the carbon paste, carbon black. We can print it as our counting electrode. That's okay. Yeah. So that's question number one. Yeah. And the another one is, does the type and size nanoparticle can influence the electrocatalytical in your sample? Yes. So we did a measurement about the size. So the sensitivity as function of size and the shape as well. So that's why the cube and the smaller size and more uniform size is the best, right? So that's what we answer number two. And also if we use other nanoparticles, yes. So for copper oxide, right? So you have some similar like titanium oxide, cobalt oxide, and also there are literature on those one as well. But at the current, we haven't really approached those methods. It's because because we just haven't really be able to prepare them electrochemically, right? So if you talk about titanium oxide and cobalt oxide, right? So how do you prepare them? And each of them have very special deposition control. So at the moment, we haven't really approached that from different routes. And we will actually pick up this idea, try to go a little further in terms of the help our commercialization of the saliva sensor. So we haven't really looked in terms of the horizontally, we haven't really looked in a wide range yet. Yeah. And what is the specific interaction between your sensor and the molecular target in your sample? Yeah, I said, so the copper oxide is the catalyst. So it's like a chemical reaction. And you have this catalyst, and the catalyst is a copper oxide promote the chemical reaction. Basically, help glucose and oxidized and become glucolic acid. And that is the signal. That is the electron get it transferred. So we are measure the electric signal if you have that reaction happen. And when we measure it, we need to add about 0.6 volts. That's kind of at a constant voltage, and we measure the current. So as you add glucose, you see if you have response, you see the current jumping, and you know you have response. You know the glucose is responsive to this catalytic reaction, right? Do you have any experience about application? Yeah. So it's quite a interesting question. So I was also going to ask about about the e-term, because each type of biosensor is quite for us, right? For me, from chemistry or physics background, it's very hard to grasp one biological reaction, right? To develop one type of biosensor is already very complicated for me, right? Because there are so many interference and other type of reaction can happen at the same time. So when, at the moment, we are really only focused on to just the glucose, which is the simplest biosensor we kind of get into. We really haven't get into depths of other type. We also try to look at the peptides, other type of peptides, but we really haven't got too far on those part. Okay, so that's kind of my answer to Mohammed. All right.
Thank you very much, Dr. Xiaojing Zhou. So we have latest also question to Professor Kyung Woo Kim. using bacteria, is it will it produce dangerous waste by using bacteria? From
Yes,
Professor.
I already replied, but I couldn't understand what is used bacteria.
Maybe
I couldn't catch the point of the question. Yeah.
Maybe he means using bacteria. By using bacteria to, I don't know, the question also is.
Yeah, the used bacteria will produce dangerous waste.
Maybe,
I couldn't catch the point.
Maybe he mean that if you filter, so you have a filter, right? So when you filter, all the bacteria get stuck into the filter. That means as you are using longer, those bacteria is going to eventually affect your water quality.
I see, but we need special condition to the bacteria survive in this condition. So maybe. So because whether their bacteria existed in the container, after filtration, we remove all the bacteria. So after filtration, the water is safe. Maybe there is a possibility of bacteria existing inside maybe the cover of the membrane, something. But anyway, the filtered water is safe.
How much it costs for your filters? Like if you talk
about that's the most frequently asked question. So our system, the small size one is now we do not produce massively, but the cost is around $200 US.
Oh, okay. So for some people that's still quite costly,
but you can use more than 10 years. So if you go camping and if there is no electricity, for example, if there is an earthquake, flooding, drought, if they have any kind of disaster, this water filtration system is quite useful.
$200 US for 10 years. That's affordable. That's pretty good. And the other thing is how accessible. So do you have those one you can just buy from the shelf, like in the supermarket or somewhere, or do you have to have some specialized people to install for you for them?
Our membrane system is very high tech. It is produced in company of Korea, but installation is quite simple. So we just connect the tubing and some tap. So just we can purchase the container in the supermarket. And we install the filter and we just make a hole and make a tap. That's it. So this is really simple.
So you don't need any like a plumber or some kind of specialized.
No, even high school student can make it in 5 minutes.
Oh, that's good. That's good. That's very important, right? If you want to do it remotely somewhere else, like in an island where people don't have training.
Sure,
right? So if you have to require a plumber to do it, that's what you have a little bit difficult. That's very interesting, And you also mentioned about a lot of arsenic in the water, in a river, in a few countries, right? So that's just produced naturally, not like any pollution or from something.
Yeah, that is not pollution. This is not point source. If it is a mining or factory. So if it is a point source, we can control the point. We can make a filtration system in the factory or in the mining site for the effluent. But this arsenic is enriched during the formation of aquifer. So this is a very large area. So in Bangladesh, more than 30% of groundwater were contaminated with arsenic. So the only way is to filter remove arsenic before drinking. That's the point of this issue.
But then you said your filter is only utilize the gravity, But how do you chemically, or how do you remove those chemically reactive stuff, like just by gravity, or you don't? I can imagine you have some kind of special recipe in your filter.
Yeah, but so our filtration is not chemically reactive. This is a physical separation. Just depending on size, we can remove. So we have two systems. Gravity-driven system is the filter size is the 10 to minus 6 meter. This is a microfiltration. So we can remove bacteria without any electricity. But for arsenic is much smaller than bacteria. So we need nanofiltration. In this nanofiltration, we need driving force, not only from the gravity. That's why we can use hand pump or pedal. So for nanofiltration, to remove arsenic, we need some driving force.
Okay, makes sense. Thank you.
Thank you very much. We have one question out. From Pak Elisa. Yes, please, Pak Elisa.
Okay, thank you very much. Directly asking to Prof. Quatriana. I interest on the electronic tank. In the video you show us, there are 3 parts of sample. And then the question is, how do the sensors clean themselves when come to the other substance, to the next, and to the next? In my mind, maybe the sample stick on the sensors and then go to the another. So it's just mixing there. So is it clean itself or not? So that's the question. Thank you very much.
Okay. Can we answer directly?
Yes, yes, please.
Thank you very much, Elisa. You're right that before continuing to use for another sample, we have to rinse the sensor. In this case, we rinse twice. The first one by using the water, because some material that salt in the water is easy to remove from the surface of the sensor. And then the second rinse is using alcohol, so it will be completed. So that's why in our system with 3 Becker class, then the first one is for rinsing using the water and then alcohol, then sensing. And then after that, we change the water and the alcohol, then we use for the new one of the rinsing of the sensors. I think it's clear. Okay.
Okay, so yeah, that's something like neutralize. Yes, thank you.
Thank you very much, Professor.
I'm wondering for your electronic tongue, is what type of sensor? Is it a chemical sensor or biosensor? What type of sensing elements is embedded there?
Yeah, basically it is a chemical sensor because it just detect the ions and the substance.
Okay. Okay. Yeah, so that's like a tongue. Our tongue cannot tell. What type of
Because actually it is not easy to produce a specific sensor for a specific substance. For example, just for it's different from the pH sensors. The sensors was just using a membrane, a glass membrane, to detect the concentration of the H plus. But in this case of the taste, is the complex, more complex rather than on the H plus. So we use the pattern rather than the specific sensor to detect the specific substance.
Because one of your sensor, you can measure your tongue, the electronic tongue. You can measure different type of coffee.
Yeah. Really.
That means the different type of coffee have different type of like iron concentration in there, different type of iron in there.
It's the possibility to use this one. Yeah.
Yeah, because that's interesting. I saw coffee there.
I think this is like our tongues. First, we have to train our tongues with the samples. And this is the A sample, this is B sample, and so on. And then we memorize. And then next we make a testing. Which one is A, which one is B, which one is so on. So our tongue, because we're using the artificial intelligence, so the system can be trained over time and train again. If we have a new substance, then we train again, and the memorized will be more perfect than before.
Okay, I see. You are not just measure the difference among them. You actually have a training first. So you say this is the Caribbean coffee or
Really?
Colombia coffee, and they taste them, and then you can say, okay, so tell me now this unknown one, which one is it, right?
Yeah.
Okay, I see.
Correct.
It got a extra process. I see.
Yeah. Another approach compared to your study. And your study, you measure a specific parameters, but we measure many parameters in one time, so we make a pattern.
Yes. You try to find the try to map a kind of a very complicated scenario, but you store in the memory like our brain.
Yeah.
And then later on and compare, right? So there's a lot of computing behind it.
Yeah. Similar like this, but because using the geometric or artificial intelligence, so we don't need like a table and also like a database, but we just need a matrix of the interconnection between neuron and so on. So it's different from the cup table directly.
Very good.
Okay, thank you very much, Professor Kuat. So, any attendees who has question, please type down or just raise your hand, and we will allow you to. We'll give you permission to ask the question directly.
No questions.
Yes, please. No question? Are there any questions?
Everything is clear, I think.
Yeah. So which means we answer all the questions.
Yeah.
We can finish. So maybe other question can be asked in the afternoon by the Q&A, so we can reply anytime. So
that's right. I think if you have any question, Pak Pascan.
Yeah. Okay. So no other question. So maybe we can conclude.
Yeah, I'm hungry. I want to eat.
That's right.
Yeah,
That's
please
right,
think about
Sojin.
time difference. We are very hungry now.
1 o'clock, almost 2. Oh, sorry about that.
Yeah.
All right.
Yeah, Pak Kuat as well. Thank you very much, Pak.
Welcome.
Before we end this session, we would like to show you certificate of appreciation that will be sent to your email after this session. So please, Pak Elisa. So this is a certificate of appreciation, Professor Chong Kim.
Yeah.
Thank you very much for your great contribution for today's plenary seminar. And next, to Professor Dr. Engineer Kuat Triana. Thank you very much, Professor,
Thank you very much.
for your great contribution, great
Thank you.
information.
Thank you.
And also the last is for Dr. Xiao Zing Zhou. Thank you very much again for your great information and contribution for this international seminar. Okay, ladies and gentlemen, before we end this seminar, please give applause to all our keynote speakers.
Virtual applause.
I believe we cannot hear, but it's okay. Okay, maybe we hope a great for you, and also take care of COVID-19.
Thank you very much. Yeah.
Okay, thank you. Bye bye.
Yeah, thank you very much.
Okay, bye bye. Thank you.
Yeah,
Bye.
bye bye. Have a nice time. And have a good appetite. Good.
Terima kasih Prof. Kuat.
Pak Kuat, terima kasih banyak Pak Kuat. Ini
Ayo Pak Elisa.
Ya, Pak.
Waduh, udah saya tahan 1 jam itu.
Nanti kita bikin Zoom lagi Pak. Waduh,
Oke.
banyak sudah mantap ini Pak Kuat. Ini pertanyaan di luaran ini sambil menunggu waktu selesai ini. Terima kasih banyak Prof.
Ya, kita kemarin udah ngobrol dengan Pak Elisa ya. Jadi hampir 1 jam Pak ya.
Iya Pak.
Ya,
Ya
nanti
gimana keadaan,
kita
Pak?
inilah. Yang penting lagi ada industri Pak. Di situ harus universitas harus membuat industri Pak.
Saya sudah
Gitu.
lihat.
Ya,
Iya.
kayaknya akan sulit kalau nggak ada industri yang melakukan proses adjustment. Gitu.
Iya Pak.
Mudah-mudahan
Menarik
nanti,
sekali, menarik industri, ikut dalam riset. Saya bisa melihat kalau kita tidak ada industri, aduh, seperti casingnya itu, aduh sudah mantap sekali Pak.
Ya, ini ada budekan tuh.
Ya, budekan.
Nah ini
Mau bicara.
material ini
Makasih
budekan.
Prof. Jadi
Ya.
kapan kami bisa diskusi nih dengan Prof lebih banyak?
Ayo, kita sudah ada rencana nanti dengan Pak Elisa. Kita bikin Zoom aja dulu.
Betul.
Iya.
Kita diskusi habis-habisan gitu, terus syukur-syukur nanti kalau udah aman dari COVID, kita bisa saling berkunjung. Dulu saya sering ke Donggala dulu. Donggala itu adalah yang bagus sekali.
Ternyata Bapak nyusup Donggala lewat Palu. Aduh. Ini yang tidak terdeteksi.
Bagus tuh.
Iya Pak. Nanti
Siap,
kita
nanti diatur
bantu
aja, Pak
Bapak
Elisa.
di sini.
Kapan kita diskusi?
Iya.
Kalau ada proyeknya Bapak di sini, kita akan garap untuk kita bisa kerjasama di sini. Saya kira itu lebih
Boleh.
penting di sini.
Kalau ada gini Pak, kalau ada komoditi yang khas di Palu misalnya ya, kemudian itu akan diautentikasi itu, saya kira juga
Kakao
menarik.
Pak. Nah, mungkin ini Pak Nenga ini. Prof. Pak Nenga, komoditi utama Palu. Ya.
Iya, kakao Prof di sini.
Kakao ya. Kakao
Iya.
itu nanti ngukur ini Pak, ngukur kadar apa namanya ya?
Kadar lemak,
Kadar lemak atau kadar apa itu namanya Pak? Asam amino ya? Atau apa?
Iya.
gitu.
Iya, termasuk itu Prof.
Ya. Itu mungkin kita bisa lakukan itu, bisa publikasi lah intinya.
Ya, insya Allah Prof, mohon bantuannya.
Ya, nanti kita
akan kita lanjuti.
Zoom
serius.
meeting aja di lain hari nanti. Kita.
Insya Allah.
Iya, insya Allah Pak.
Prof, teman-teman bertanya, siapa tahu Fakultas MIPA bisa dapat genos.
Oh.
Ya, saya nggak jualan.
Mau kopi ya?
Saya itu punya satu, dikasih oleh pabrik.
Iya.
Sekarang dipakai mahasiswa untuk mendeteksi itu luka diabetes. Nah, terus kemudian ini udah berapa ya? 4 bulan nggak kembali.
Industri yang punya.
Jadi kami nggak jualan. Jadi
Ternyata saya kira banyak di sana Pak. Ternyata
Enggak,
di industri
enggak ada
ya. Ya, license.
nggak ada. Jadi license kan udah kita lepas ke industri dan
begitu
kita
ya.
iya, jadi kita sudah nggak ngurusi itu lagi. Gitu. Itu sih.
Banyak sekali produknya, Prof.
Ya, siaplah nanti kita kolaborasi apalah gitu yang kita dapat
Iya,
diskusikan setelah ini.
Ya. Ini Pak Elisa dia hobi elektronika juga, Prof.
Ya, kemarin udah cerita beliau. Ternyata
Iya, Pak.
muridnya Pak Mitra Jamal juga.
Pak Mitra. Prof Mitra.
Pak Mitra ya. Oke. Silakan nanti kita bisa diskusi mengenai. Kami juga ngembangin ini material untuk sensor juga, termasuk juga alat-alat untuk karakterisasinya juga kita ada. Kalau ada yang mau belajar bikin elektrospinning, silakan ke Jogja saya ajarin. Jadi nanti bisa bikin nanofiber, Bu. Jadi mesin untuk membuat nanofiber. Nah, gitu.
Keren. Keren itu, Prof. Nanti
Ya,
kami
jadi,
lagi, Prof.
Kami buat sendiri semua karena nggak punya uang.
Iya, ya.
Iya.
Karena faktor kemiskinan lah gitu ya. Nah, kemiskinan itu harus mampu untuk membuat dengan biaya yang murah gitu.
Iya, itu yang harus kita kembangkan.
Betul.
Jangan selalu kami ini selalu alasan tidak ada alat.
Ya. Saya udah bilang Pak Elisa itu, Pak, kalau datang ke lab saya, semua alat dibuat sendiri.
Ya, Pak.
Alat fabrikasi dibuat sendiri, karakterisasi dibuat sendiri. Tapi jika alhamdulillah tembus tuh ke international journal juga artinya nggak masalah gitu.
Itu yang memang dari yang tidak ada bisa kita publikasi ya. Ini yang menarik dari Pak Prof ini, dan mungkin bagi yang masih ada ini bisa melihat sebagai
silakan
motivasi.
kalau ada yang mau ke Jogja yang bisa elektronika, nanti saya tunjukkan bagaimana cara membuat mesin untuk fabrikasi nanofiber gitu. Kan di situ
Mungkin
banyak
ini kunjungan khusus nanti ini budekan ini bisa kita dikirim ke sana ini. Saya tertarik untuk itu. Nah,
temanya satu orang gitu nanti kembali udah pinter nanti.
Kampus masih tutup ya?
Ya, kampus tutup ya. Kampus tutup. Kami juga tutup, tapi kami untuk yang mahasiswa yang sudah final sudah mendesak gitu juga kami izinkan untuk kerja di lab. Jadi tidak tutup sama sekali.
Iya.
Oke, Bu Dekan, Pak Elisa, Pak Tengah, dan Bapak Ibu sekalian, senang sekali bisa ketemu di layar maya gitu. Nanti kita lanjutkan dengan diskusi via Zoom dulu. Kita cerita-cerita kita punya apa, kemudian kita sharing begitu. Dan mudah-mudahan ada juga yang bisa kita share gitu ya. Mudah-mudahan kalau saya suka kalau teman-teman juga bisa mengakses di tempat kami sehingga kita bisa bersama-sama lah gitu untuk ikut maju bersama lah gitu ya.
Oh, siap.
Saya mohon izin ya. Kebetulan ini saya ada acara lain lagi.
Terima kasih.
Terima kasih. Matur nuwun, Prof.
Dan sukses semuanya, sehat semuanya, dan nanti kita ketemu lagi.
Ya.
Mohon pamit ya. Mohon izin.
Mohon. Silakan Pak.
Ya, terima kasih.
Dan bagi Bapak Ibu yang masih ada, saya kira untuk sesi opening dan plenary session 1 untuk hari ini sudah selesai. Dari kami harapkan untuk bersiap pada sesi berikutnya nanti, sesi paralel dari jam 1 di sini, berarti kalau waktu Indonesia Barat jam 12 sampai jam 16, kalau di sini jam 17. Kalau Indonesia Timur jam 18. Wah, ya begitulah. Kita ada di 3 zona yang berbeda. Dan sekali lagi terima kasih banyak atas kehadirannya. Sekaligus besok kami undang lagi untuk hadir di hari kedua dalam sesi plenary yang kedua. Jadi harap mengikuti karena banyak hal yang menarik untuk dilihat dan disaksikan. Demikian saya kira, dan saya akan selesai di sini mengambil alih untuk kegiatan. Terima kasih. Selamat mempersiapkan diri untuk sesi paralel nanti. Demikian juga untuk hadir besok dan juga pada paralel session juga di sore harinya. Terima kasih dan selamat siang. Salam sehat selalu.
Assalamualaikum.
Baik, recording progress. Aduh.